This time we're going to look at a vintage old piece of test equipment that was found in pretty much every TV repair shop in the country. Well, most of them anyway. Had one at the first shop that I worked at. Second shop, nope, the guy was too cheap. He would buy nothing. He would tell me if I wanted any tools that I had to buy them myself. But this is a unique piece. I think you guys will get a kick out of this one. Check it out. This is a B&K Precision Television Analyst Model 1075. So what this piece of test equipment did or does is it generates test patterns and test signals that was used for repairing old school televisions back in the day. You could output any channel from channel 2 all the way to channel 13, or you could output an IF signal from 25 all the way to 45 megahertz. Actually, probably go lower than that, but 25 is here. I can tune below that. You had an RF output. You had an audio input, so you could send audio or tone. So you could send just a 400, I think it was a 400 hertz tone, or you could apply audio and it would modulate it. You had RF and IF output. It also had, I believe it had video output. Yes, it had video output, positive or negative polarity between video and ground, and a video level control and horizontal drive. You could drive the horizontal grid drive for driving a flyback, for example, and vertical grid drive, so that if your television that you were testing had a failure in either the horizontal oscillator or the vertical oscillator, you could actually drive the grid for the output tube and verify that you had sweep. So it would generate those signals. It had a 400 hertz audio tone and a 4.5 megahertz sound with the 3.58 color subcarrier. If you turn the color on and off, but it would probably also be present on the video. I haven't even plugged this thing in since I got it. The screws are missing. I can pull this thing apart. We will slide the chassis out and take a look at it. You'll find this thing's quite unique in how it generates its test patterns. It uses what's called a flying spot. This is the slide that I've got for it. And inside here there's just a CRT and a photomultiplier tube. And the CRT, as it scans this slide and will produce that image. Very much like the old monoscope cameras. In fact, it is essentially a monoscope camera is what this is. Working exactly the same way. The true monoscope camera had a CRT that had a metal grid in it that read out the video. But this works very, very similar. It uses a CRT with a beam that's scanning it, and it just lights up an ultraviolet phosphorus which passes through this slide and is picked up by a photomultiplier tube which produces the video signal. Anyway, had one of these at the very first shop that I worked at. Only used it a handful of times. I always thought it was kind of cool, and when I had the opportunity to pick this thing up for nothing, I said, yeah, I'll take it. So let's pull this chassis apart. We'll power it up and see if it actually even turns on, because I don't know the state of how this is. I don't know the condition. It probably is going to need a restoration, but let's power it up and see whether it actually does anything today. Thing that does make me nervous is that the access panel from the back is missing, so the tubes and everything are all exposed on here. I could probably plug it in right now and just see whether it turns on. I'm going to fix a new piece of metal on the back here just to protect that picture tube. I'll power it up on the dim bulb tester first and see what happens, see whether the tubes light up. So when I put it into standby, I notice that the light lights up quite bright. This will just be for heating the filaments. So as you can see, the bulb is dimming a bit as the filaments start to heat up. I'll let the filaments heat up for a few minutes before I apply full power, and we'll see whether this thing produces any type of light from the CRT. As we can see, the tubes are warming up quite nicely. I don't know whether I'm going to get a raster on that CRT or not. We're just going to give it a few minutes to warm up and see whether it actually produces a raster. I see that I've got high voltage. If I put my screwdriver in here near the high voltage rectifier tube, we'll see I can draw an arc. Do you see the arc in there? Let's see if you can see it on the end of the screwdriver. So we have high voltage. So we know the oscillator's running. If we look down in the slot on the top where the slide goes, you'll see that I have a bit of a raster. So we have a raster on here. Now what type of signal I'm going to get out of it, that is yet to be seen. I'll put the slide in there and we'll see if we get any video coming out. But this thing appears to be working. It looks blue because it's ultraviolet. It's an ultraviolet phosphorus on here that is used to create the video signal. So that slide that I just showed you, it goes down in here. It sits down in the front here somehow. It slides into a slot. Slides into a slot there and sits in place like that. We should have a video signal and an RF signal coming out of this unit right now if I hook it up to a TV. One thing I didn't get is I don't have the proper connectors to connect onto these, like a mic connector type, old-fashioned type mic connector with a screw on and a center pin. I don't have one. I don't have an adapter for that. So but the best I can do is just take the coax and just kind of stick it to there and see what we get. This thing works. Excellent. Channel 5. Tune it in here. Probably as good as it's going to be. I don't have a shield on here, so maybe if I can get the ground on, it'll be better. Turn on the color and it throws a color signal on there as well. A rainbow color signal. Some of them used a gated rainbow. This one's just a full color sweep, just to validate that the color system is working on the TV. Right? So that just shows you that it's putting on a rainbow pattern, but not a gated rainbow, just a full field. Turn the color off. So this thing's working actually a lot better than I thought it was going to be. Just going to try to make a few adjustments. How this thing is set up, and I should probably take it apart and clean it. Maybe I'll do that. I'll clean the photo multiplier tube in there. So I'll just put this thing to standby and shut it off for now. So what I'm going to do is I'm going to give this thing a more modern RF output if I can from the inside. We're going to pull it apart, take a look at it. I'm going to clean the photo multiplier tube, and we'll clean the front of the CRT, because obviously any dust and dirt on that is going to impact the image quality on that test slide. And you could put anything on that you want. You could make a test slide that gives you a middle finger if you want, right on there. But we're going to clean this up because you see there's some dirt on here. We're going to clean this up. We're going to clean the surface of the tube itself and the photo multiplier tube. But to do that, I got to pull it apart. So let's do that. Let's remove it from the cabinet. I tell you, when I was a young tech, this was the holy grail, a piece of test equipment that I wanted. Everybody wanted one of these things because, well, they were just so damn cool. We had one at the shop, and it was one that the lid lifted up on it. This one here is a different model. See, the chassis should just slide out on this thing. Gotta be careful not to break that tube. We'll slide out the front chassis so we can see the inner workings of this unit. It'll all come apart. It should all slide out. This is far enough to actually clean it anyway. What's holding it up? I think the screws are all out of the bottom, so this should just slide right out. Although as far as cleaning it goes, this is really as far as I need to get it, because I can get to the CRT and I can get to the photo multiplier tube, which is this one right here. You see? So basically what happens is that CRT has a raster on it, ultraviolet. The slide sits in front of it, and the image, as the beam passes through the slide, the white and black lines modulate that flying spot, either allow the light to pass through or block the light, and that light lands on this photo multiplier tube right there, which is an open grid. We'll try to pull this out. I hope I don't break it so you can see it. And basically it's an open grid, and when light hits it, it excites electrons, and electrons then fly through and hit the plate and modulate the plate with video. Okay, there's the photo multiplier tube there. You see what I mean? This is a 7117, and there's the opening where you see the grid. And basically what happens is when light enters through the front of the tube here, striking the photocathode knocks electrons off, which are amplified through the dye nodes and picked up at the anode. Someone can correct me if I'm wrong, because I'm not really 100% sure, but I know that the electrons get knocked off of the photocathode and it propels them. The light hits them and moves them, and they then modulate through to the plate, and the signal's picked up on the plate. I'm going to get something to clean this with. We're going to clean up the tube, clean up the surface of the tube here. And I'm not going to pull this apart anymore. I don't want to risk damaging anything. It doesn't want to slide apart. It should just slip right out, but it doesn't seem to want to move, so I don't want to damage it. It's working, so we're going to do some adjustments. I'm not even going to change out the caps on this thing, because they all appear to be working okay at this point. And see if we can get the linearity and so forth kind of right on the tube. The adjustments are all on the side here. They're adjustable through a screw hole on the side, a screwdriver hole. So let me clean this up, and we'll give it a try and see if we can get a good picture out of it. But this is exciting, because I've had this thing now for a couple of years. It was given to me from a fellow that was a friend of a friend, basically. Friend of mine knew the family that owned this, and the fellow passed away, and I was invited to help clean out the house before they tore the house down. And I pulled a couple Betamax machines, and I pulled my Akai stereo that I use in the shop. And this was one of the pieces of equipment that he had. I thought, oh, you got a television analyst, what the hell? I'll take this. The guy was just a collector of old junk. I mean, the whole house was just full of crap. I mean, the stuff I got out of that place, certainly collector's items. I got a brand new 15 watt, 18 inch fluorescent blacklight in the case, never been used. I got a brand new garage heater identical to the one that I've got here, which I sold. Still in the box, never been opened. The guy had quite the collection of equipment, and a whole bunch of turntables, which I've sold most of them, and amplifiers and receivers, and most of that stuff I just got rid of. I sold it off cheap. But I hung on to this piece because I figured this is a piece of television history, and I hadn't plugged it in until today. But let's clean this thing up and see how good I can make it look. So I'm just wiping the inside of the tube with a cloth with some Windex on it. A little bit of dust on there, and we'll do the same for the photomultiplier tube. We'll just clean this off, get it nice and shiny, especially on that windowed area. That's the critical part. Reinstall. Because the window is in line with the getter here. So the window's actually facing that way. The light enters it from an angle. So we'll push the chassis back in now. I'm going to fix up a connector that I can attach to the front here and hook up an RF cable to it. Well, this unit I expect it was designed for back in the days when everything had 300 ohms output. So I'm going to attach a 300 ohm transformer to the front here. I'll just solder it down to the RFI of output. And that should be able to hook up my coax to it and give me an adequate output for testing purposes. I just got a message here. What's my message? Okay, looks like I'm getting a free Betamax machine that doesn't work. Wonderful. Get a free Betamax to fix. Always like fixing old Betamaxes. Gonna flow some solder right onto the top of this connector, and I'll just solder the wires down to the shield, or to the ground, and to the center pin. As you can see, it'll attach no problem here. I could have done it on the inside too. I just didn't feel like opening it up any further than I did. I could have probably done it from the bottom. But this will get the job done. This will provide me an output that's connected to the unit. That will give me a good solid output. Now we can hook it up to the TV and set it up. That's looking a lot better. That's actually almost presentable. I can find what controls I need to adjust on the side here, what type of screwdriver I need. Probably just a red slot will do it. I'm just looking to see my flashlight so I can see where the control is. It's probably hidden way down inside here. What is it? It's a okay, horizontal size, vertical size. We'll start out with this one. So what I'm going to be adjusting is I'm adjusting the actual scan size of the picture on the CRT inside this unit. And by adjusting this, this should affect the I can get the screwdriver into the slot here. This should affect the actual horizontal size there, you see. The idea is to make the linearity round on here. It's still a little bit off. These were never the most accurate things in the world, but with careful adjustment, I should be able to get that picture relatively round. The center, a round circle should be round. That's me moving the slide around. If you take the slide right out, you'll just get a white screen from the actual tube itself. Now this thing is drifting a bit as it's warming up here. I'm sure these old capacitors are reforming as they sit charging up because they've been discharged for so long, but it's actually not looking too bad for an ancient piece of equipment. If we look at the horizontal lines of resolution here, it looks like this TV's fallen off around 200 lines. So it looks like to me, not the sharpest set in the world anyway, it's an old RCA CRT set, but linearity wise it's getting a little better. I can adjust the vertical size and the linearity. And basically what I'm doing is I'm adjusting. Oh, that's looking better already. It's almost looking round now, isn't it? Nice burn-in on that screen from back in the day when this set was being used as a monitor for my security cameras. You can see my back door and back window there quite nicely, and the front door at the bottom left corner of that was where the front door camera was, and then the back door, and then the other two were the driveway. Let's check all the channels out. Let's try channel 2. Find my remote. Channel 2. Tune this down to 2. There's 2. 3. 4. 5. Oops. How about 6? I just put, okay, now 7. I should also do 7. I can figure out how to do it. Just go to here. There's 7. It puts it out on 2 channels at the same time. There's 7. 8. There's 8. 9. 10. Should do all the VHF channels. There's 10, 11, 12, 13, 13. So those are all the channels. I'm just rocking this thing back and forth a bit. And of course, I'm just changing the channel by adjusting this tuning. So if I go back to, say, channel 5 on my TV, right now it's pointing at 13. If I just turn it up like that, that's 5. So it's actually putting it out in 2 places on the band at the same time. If I go back to 13 and tune it down to 13, that's almost the same as 4. What happens if I go to 4? Will I see a picture? Probably. And I do. I see a picture on channel 4 at the same time. So it's actually outputting on 2. It's outputting on the low band and the high band at the same time. That's interesting. And if you were to select IF output, then of course it's going to just adjust the IF, and I might even be able to inject IF through the tuner on this thing. Let's just see if I can. Oh yeah, there we go. You see? IF is passing straight through the tuner right into the IF strip. As you can see, if I adjust the RF tuning, nothing happens. Now it's just the IF tuning. And I can tune this thing through the entire IF band. And this is passing right through the tuner. It doesn't give a damn what channel the TV's on. I can select any channel on this TV. There, I just offset it there. When I adjust the horizontal control on here, that's what changes the horizontal sync, and it actually shifts it. It actually changes the size, you see? And that's just this control on the front. This one, horizontal. Video level changes the video level. I can brighten it up or dim it down. So that's the video level. It's got an output for RF, IF, and video. Video polarity doesn't seem to make any difference whether it's negative or positive. Changes it ever so slightly. I'll show you the screen, but it's not inverting it or anything. So video is set to positive now, and I switch it to negative. RF attenuator, so I can dial the signal level back to simulate a weak signal or a strong signal. Cat's calling me. Cat wants to play, I guess. I don't hear a tone on here. I thought there was tone on, but I don't hear audio tone. The audio input works. I guess the audio oscillator is not working. Because if I touch the audio input, I get sound. If I take my MP3 player, I'm sure I'll hear sound through the TV. Let's try it. Audio. The tone's not working. Audio is. Audio input is. You can turn it right off and it kills the audio subcarrier, you see? But if that's the only thing that's wrong with this thing, I think I can live with that. Old vintage piece of test equipment. I'm going to find a metal plate and put it on the back to protect that CRT that's sitting wide open, and maybe find a few screws to hold this thing together. But overall, I can say this was a pretty good score to get this for free, and it works. As you can see, the back is wide open on this unit, but I just happen to have a back plate from an old amplifier, an old car amplifier. And I think that if I put some screws through there and screw that on, that will protect the CRT from any accidental damage of something falling into the back. That's always what's been my concern. It's been under my bench for like the last 2 years almost. I was always paranoid something was going to fall and land in there and break that CRT. So we're going to protect it. When you know my screwdriver battery's dead. There, that'll hold that one in, and then another one, just one more screw down the bottom corner here will hold this other side on. That's more than enough, and there's enough room for the cord to come out without being damaged, so we'll just get this other one. This is a self-drilling screw. These are great. It's got that little drilling piece on the end. Put it in there. Kind of killed two birds with one stone on this one. It actually went right into the chassis, which pulled the chassis back, so I don't need to put screws into the front now to hold the unit together. That one screw will hold the chassis in. And I got enough clearance here so that the power cord can slip through without becoming a problem. Now the CRT is protected and my unit is fully functional. There's one last look down the top. You'll see the CRT glowing away there. I'll kill the lights in here so that it shows up a little better. That's why it's in a dark cabinet. But you'll see the CRT just glows, and that's what illuminates that slide. It's a nice deep purple ultraviolet color. Actually a little darker than what appears on camera. I'm looking at it here, but it is an ultraviolet tube, ultraviolet phosphorus that's glowing, and that's what provides the light for the slide. If I move the slide up, you'll see, if I pull it up on the screen here, for example, I'll show you the screen. Certainly does look like over the years this has had a fair bit of use. You can see yellowing of the, maybe that's, oh, you know what, that's probably nicotine. It was probably in a shop where the guy smoked. If I put it in backwards, it'll obviously appear backwards on the screen. That's why it says front. There used to be a knob here to pull this forward to access the slide tray. This one was designed so you could easily change the slides from one to another. So I think that's probably about as good as it's going to get. I've got it going through a splitter now. The cable's split like 5 ways, so the signal obviously is going to be a bit weaker just because it's going through a bunch of splitters. But it certainly is working a lot better on a CRT set, which is of course what these were designed for. There was no digital TVs back in the era of this thing. Most people had black and white TVs and maybe some color, so we can turn on the color generator and then you can see the color. This one's not the same. That doesn't do a gated rainbow, but it does do the color on the screen. I can turn the video down and just look at the color, or bring the video right up with the color, because the color is a fixed level. And here it is displaying on my plasma. I put it into a cable splitter and got it displaying on the plasma screen as well. As good as I can expect it. If I turn on the color, there's the color turned on the plasma. If I adjust the video level, of course I can turn the video right off and keep the chroma on, so then it goes through all the colors of the rainbow, through all the vectors for chroma demodulation. Bring the video back up in the background. I think this is probably about as good as this thing probably ever looked, you know. If I pull the slide away from the tube, it'll go out of focus. As you can see, the slide has to be right up against the actual tube itself, the flying spot. But yeah, maybe when it was new it could do a little bit better resolution than this, but I guess, granted, considering the age of it, and I haven't done anything to it, I haven't changed any parts, I haven't changed any caps or anything, it probably could use some caps. We see a little bit of flickering and so forth there, so maybe for a future project we'll pull this thing apart and I'll go in there and we'll change out all the caps on it and see if we can make it look better. But for the initial preliminary look at this old beast, it's working. That's a pass right there. So if you notice, the size keeps changing slightly, and it also will fade right out. It'll just go black and come back. I'd give it a whack on the side and it comes back. So I think we got something loose inside. So let's pull this one apart now and just see if it's just a loose tube or something, because it's not behaving right. So this is the inside of the TV Analyst. I should blow this dust out first. I'm going to get my air compressor. We're going to blow the dust off of this thing first. and then we can take a look at it and see, power it up and so forth, and see if I can get it working a little better than it's working. Here's where the slide goes there onto that CRT. The reason I couldn't get it apart was this was catching on the inside of the cabinet. I actually had to pull this forward in order to get enough clearance to get the back off of it. We're going to have to shield this from light, otherwise I won't get any output from it on the TV, because the ambient light will kill the tube, and it doesn't do them any good either. It's hard on them. Make sure all the tubes are seated. But first things first, let me go get my compressor and we'll blow this air out of here, or blow the dust out of here, because this is just full of dust. Okay, I got it going now. I'm just trying to adjust it. The lights in here aren't affecting it too much because they are, for the most part, they are LEDs. So there's not a lot of ultraviolet that's affecting this, and I'm getting a picture on the screen. The slide wasn't in the proper position for one, so I've repositioned it so that it's filling the raster correctly now. I just having to adjust the height and the width to try to get this thing to look the nicest on the screen, give me the roundest picture, for example. And I'm getting there. Slowly but surely, I am getting a round picture. Basically what you need to do is you need to scan the complete frame and not much more. My CRT was dimming out a bit before, and I'd give it a bang and it would come back, but a lot of these tubes were loose and I just pushed them all back into their sockets. And that seems to have solved that problem with the actual raster dropping out on the CRT. Some people would refer to this as a monoscope, but it actually isn't. It's a CRT. A monoscope has the test pattern that's actually built right into the target. I'll show you some pictures of a monoscope that generated the test pattern for TV stations. But this does the same thing. It's just that it does it with a slide that you can remove and change. But this has phosphorus that over time could burn, especially if you lost drive to it. A monoscope tube, if you lost drive, it's not going to burn anything. It's just, you're just going to get a line, right? The principle is the same. In this case, it's just this. It's converting the electron beam to light, passing it through the transparency, and then converting the image that's picked up back to a video signal, whereas a real monoscope tube produces the video signal of that static image internally and reads it right out of the tube. Yeah, somebody's been messing with the settings on here because the paint that seals the magnets on the yoke, which position the raster, have all been broken. So by adjusting these, I can show you, I can center it on the screen and get the picture looking like it's supposed to look. As you can see, that is looking a lot better than before. I've got my linearity problem pretty much solved, and of course I can adjust the position of the raster to make it fill the screen properly. And we're just going to adjust the vertical height and the width a little better on here and try to get this filling the full screen so that it looks like a proper monoscope. So there's a good shot of the actual tube itself, how it's illuminated. It just goes through that slide, and I say I could put anything in there I wanted. I could put I could print my own test pattern. I could put the Indian head on there. On the monoscope camera, the etching was actually done on the plate. It was, instead of it having a phosphorus screen, they actually put a metal target on the tube itself, which had that was etched into a metal screen that was put in place of the like where the phosphorus screen would be on a CRT. They had a metal screen there that did the same thing, and then test pattern, the Indian head test pattern, was etched in on a screen that was integral part of the tube itself, with the video signal being read directly out of the tube. But this works basically the same way. This one here, you're producing a raster. In this case, the raster is being produced on just an ultraviolet, just a plain raster. This was also used for some early film scanners as well that did the same idea. They used a white phosphorus, and the film was pulled in front of it, and as it was scanned, the 3 photomultiplier tubes, one with a red, one with a green, and one with a blue filter in front of it, would pick up the 3 colors and produce an image. And telecines such as the Rank Sintel did that, and Kodak even had one for 8mm or Super 8. We had one at the station I worked at, and I wish I could have snagged that thing, but it used a little CRT like this to scan 8mm, not 8mm, Super 8 film. It would scan Super 8, and it was a small little tube. It was only like about, I think it was about 2 inches in diameter. It was a little small tube, little white tube, and it had a scan that went across it as the film was pulled through it, and it would scan the film, and it would track the film at the same speed. It would scan it at the same speed that the film was moving. Pretty cool device. But this thing's looking a heck of a lot better than it was when I first started on this project earlier today. I would say that is probably about as good as we've gotten it so far. Maybe take the width out a little bit wider just to fill the screen, but I mean, with the slide in there right now, that's framed up pretty good. Although I'd say it's a little bit on the small side. I think it should be a little bit wider than that. It's looking pretty good as far as the linearity of it goes and all. Okay, I've killed the plasma because that was apparently causing some interference. When I had the plasma running, watch what happens. You're going to get noise from the plasma. It's going to cause lines because the photomultiplier is so sensitive. See the lines come back in the screen there? Turn it off. And they go away. I think this is probably as good as I'm going to get this. As you can see, it's filling the entire screen now. And I haven't had to put any parts in. I just pulled it apart and reseated the tubes, because some of the tubes were a little bit loose on here, and blew out all the dust. And it seems to be hanging in there, producing a really nice picture on that old CRT set. Even on the plasma, it doesn't look too bad. You can see it's going almost up to the full 325 lines. If we look on the screen here, you can resolve it. If I zoom in a little more closer here to it, right, you're seeing we're getting up over 250 lines for sure. It's hard to tell on the monitor here, but it sure looks like we're getting very close to 325 lines right in here. Starting to fade out right around there. So it's certainly is performing okay. So I've still got the top off of it, and I'm sitting in the dark here just because any light getting into this thing will cause problems. Like, for example, if I turn on a light, watch what happens if I bring a light anywhere near it. The picture will just go away because it's just going to kill the photomultiplier tube, right? So that's why it's in a box to keep it dark. But I'd have to say that this thing is, other than the fact that the 400 hertz oscillator is not working, I'm not really that concerned about that. I know that the external audio in works fine. But the 400 hertz oscillator is not working. I'm not really that worried about that aspect of it, because not like I'm going to be using this thing for anything anyway other than to play around with, and if I want to generate a monoscope test signal. There it is. For what it's worth, this sucker is working. I'll put the camera around here so you guys can just admire the build of this thing once again before I throw it together. So here's the unit, and it's still working. I'm not shining any light directly onto the photo multiplier, but we've got in here, I'll point these out, damper tube for the horizontal output, and that drives into the flyback transformer. This little tube here, this is the, you can see I'm drawing an arc there. That's the high voltage rectifier that is generating the high voltage for the second anode for the CRT. Got a conventional yoke on here. On the other side there's going to be the vertical deflection circuit, so I'll spin it around here in a second so you guys can see that. This front end here, this is the video processing circuitry. So the back end here, this generates just, it's like a regular television receiver. It has a horizontal oscillator. There'll be a horizontal oscillator tube. That would be this one down here. That's a horizontal oscillator tube. Bring the camera in a little closer view there. So there's the horizontal oscillator tube. And then on the other side over here, you've got the vertical oscillator and output. And I think it's probably, there's two tubes in here. One of these is going to be the vertical oscillator, more than likely this one closer to the front, that one over there, and that's going to be the vertical output tube, and the vertical output transformer, more than likely I think it's got an output transformer right there. That drives the yoke, and that's just generating a standard raster like any CRT television would have. You could modulate video onto this. It is a CRT. But there's no video amplifiers driving it. It's driven with a constant current source. There's adjustments down on the side for the beam current that is set to a low level because you don't need a lot of light. You just need a little bit of light to pass through the slide. And then on the front end over here, the image passing through the slide is picked up by the photo multiplier tube, which is this guy down here. And if I move my screwdriver in front of it, actually you can see it. If I move my screwdriver in front, you will see a shadow from me blocking the light. And in the most simplistic terms, this is basically a film scanner. It's scanning one frame of film. But the light passing through the slide is picked up by the photo multiplier tube, which amplifies it. Then it goes into the video amplification stage. There's a color crystal over here, 3.579545 megahertz crystal. It's right there. That generates a color for when you flip on the color circuit so that it can display that color rainbow. As you saw before, that's what the color does. It just generates a 3.579545 subcarrier with a rotating color field through all of the vectors. That's to prove your color circuit's working on your television. Also in here there would be the audio generator and the audio subcarrier, likely this side over here. Again, no tone. Could be one of these tubes is bad. There's also an adjustment down there. I don't know what that does. I haven't looked at the manual, but anyway, this thing appeared to be working perfectly now, so it's time to throw it together. Anyway, I think I'm going to throw this together now. It's working really good. I'm happy with how it's looking. If the tube is clean enough, I'll just put it in standby here for a minute. We'll just make sure that that tube is clean before I throw it all together. I did wipe it before, but now that it's apart, it might be a little easier to... I saw a little speck on there, so maybe we'll wipe that off. Oh yeah, there we go. So we'll turn it back on now that I've cleaned the tube. There's our raster. It's looking good. Make sure that my slide is clean and there's no debris on it as well. We'll put the slide back in. There we go. Looking good. This camera can sure pick it up good. All the way to the 325 lines, no problem. Okay, I think I'm going to end it now. I think that's about as good as I'm going to get this thing looking. That resolution looks good. What I've done is I took off the splitter So it's going straight into the TV. I can turn the RF gain down to simulate a weak station. That's all the way at the minimum now. And then back up to maximum. And I got my sync, horizontal sync level. I can change that if I bring it up. I guess this probably just changes the width of the horizontal, because it'll bring it in a bit. Right? And then if I go down too low, of course I lose sync. So this is affecting the sync level on the video. But looking good. Linearity is looking pretty damn good on this thing now. It's got good video level. This is fixed. This is looking great. It probably didn't look much better when it was new, and I haven't put any parts in it. Just some setup, tweaking it a little bit, cleaning it, and reseating all the tubes there was a few of them that were a little bit loose. Anyway, thanks for watching. We'll catch you again in the next one real soon. Bye for now.